Okay, we're going to finish installing the pinion. The parts for there are, you have the threaded ring that also holds the seal. I've knocked the old seal out and put in a new seal here. This is what's called the seal ring. This rides on the pinion shaft, and the outer diameter of it rides against the seal. You may be able to see, this is an original one, and it's got a bevel on this side and a bevel on this side, and you can see the wear line where the seal's been riding against it. The newer ones that BMW is supplying don't have either of the bevels. For a while they had one with the bevel on one side, and now they don't have any bevels, and it's much easier to install with less risk of damage to the seal if they have the bevel. So whenever I can, I use the old seal ring, and what you do is you just flip it around and you've got a good surface there. I've wire brushed off any corrosion that's here. There's a little bit of staining, but that's not going to be a problem. So we're going to be good on that. I can just go ahead and, because he has the bevel, I can go ahead and put him in either now or later. I'll go ahead and put him in later. The seal ring, I cleaned out the threads on that. Has the traces of the Hylamar on it. We're going to put a little bit of new Hylamar on. This is the aero grade Hylamar that has the acetone, and it's not my favorite formulation, but it's very easy to spread. And then the acetone evaporates, or whatever the carrier is, evaporates and leaves you a little bit of goo on there, which is enough to seal the outsides of those threads. Wipe that stuff off. So we can go ahead and install him onto our tool. Very fine threads, so a lot of times what you want to do on fine threads is rotate backward ever so slightly. Just to make sure you're catching a good new thread in there. He gets tightened to about 118, where BMW comes up with some of these numbers. Pretty sure. Okay, so now we can push our seal ring in there, making sure to install it on a side that hasn't been used yet. Just work him around the shaft. Now we need to, in order to install the pinion nut, that's going to try to turn the pinion. And we need to be able to immobilize the pinion to do that. So we're going to reinstall the cover onto the ring here so that we can use that to immobilize it. The shim that was in here was a 1mm shim. No one is ever going to need a 1mm shim here, or almost never. I'd be very surprised if this one used it. But for our purposes it's good because it'll actually let us over compress the stack a little bit, which helps us which will help us establish the backlash, which is the next thing we're going to do. So the covers take very little heat to slip on. So rather than use the oven, I'm just going to warm it up with the torch. So I've taken the O-ring off the cover so that we can install this and uninstall it a bit more easily. You don't need to put all the bolts in for these purposes. That's good. Just gotta go grab our red Loctite. So we have red Loctite, pinion nut. We're going to go back to use this handy dandy tool for immobilizing the ring gear and the fixture. We're going to ramp the torque up to 200 Newton meters. Engaged. And there we go. Pinion's installed. I'm just going to loosen these ever so slightly so I can feel the pinion turn. Feels pretty reasonable. So at this point, I'm going to show you the backlash. I don't want these to be too tight because it makes it hard to feel the backlash. But you want it to be even, so I try to bottom the bolts all out and then back them off the same amount. So that the bearing is slightly compressed. So at this point we need to mobilize the pinion shaft. I generally do with a long set of needle nose vice grips on here. Then we'll use the bungee cord to immobilize the pinion. It's also worth tightening these set screws here, which keep the final drive from rocking back and forth in the fixture. Because you really want to take all of the play out of it. And then there's one more tool I need to get. Hang on. Okay, the last thing I'm going to show you here for the moment is I'm going to demonstrate what the backlash actually is. As you can see here, we've immobilized the pinion by grabbing it in these vice grips and strapping it down with the bungee cord. So now, the way the design is of the teeth, there's a certain amount of clearance between the teeth on the pinion gear and the teeth on the ring gear. And you can see that by seeing this little bit of motion here, and you can actually hear the teeth clicking off each other. So the amount of that motion is controlled by specification, which is that at the gear teeth, and the gear teeth are about here, at the gear teeth there is between 7 and 16 hundredths of a millimeter of slop back and forth. Most final drives that I see are set up with too much backlash. It's not uncommon for me to take out 20 hundredths of a millimeter of backlash. This one feels like it's slightly over spec, but not much. I'm going to go ahead and measure that, and then I'll show you how we're going to change the shim on that. Okay, I've pulled the ring gear back out. I measured the backlash at about 22 hundredths of a millimeter. So going down one size on the backlash shim will probably bring us into spec. So let's go ahead and pull this bearing off. We can see what size shim is under there, and then go ahead and try to make it better. So here's our backlash shim sitting down here. They have markings on them when they're new. Probably won't be able to read this one. Actually can. Looks like a 215. Yep, sure enough. 215. Okay, well I set aside some shims here, so I'm going to put this back in the 215 pile, and I'm going to grab a 210. Wipe off the stub, and remember we waited to put the new bearing on until we'd had a first chance to look at the backlash shim. So stuck in there. So I'm going to head over to the press real fast, press this guy back on over that shim. Okay, we're back, and hopefully we're just going to finish up this final drive here. I ended up switching for a different backlash shim because I still wasn't happy with the one that we put in, and you can't feel it quite the same way now, but now we are right in the upper half of the spec range for backlash. So I'm good with that. We've the backlash shim is now sitting in here between the new bearing and the axle. Our pinion shaft is in there with the seal. Our new bearing race is in there. So this guy is going to go in there pretty much for good. So all that's left now is to check the shimming of the cover. And basically you have here's the cover itself, and what you're trying to do is measure from the clamping surface down to where the bearing sits. And that's basically the amount of space that you have inside the cover. And over here on the final drive, you have the bearing sitting above the clamping surface. And so you're going to take this measurement from the bearing down to the clamping surface, and you're going to compare it to the equivalent measurement over here. Then you're going to calculate in the amount of compression that BMW wants you to have in there, which is 5 to 10 hundredths of a millimeter. And then you're going to choose shims, and I have an array of our shims here that we're going to use, ranging from very, very thin ones that are 15 hundredths of a millimeter, ranging all the way up here to ones that are a full millimeter thick. We generally use stuff that's in the 0.5 millimeter, 0.6, 0.7 kind of thing. Actually, this is a 5, 7, 8, 9. I don't have any 6s. They sort of come and go. So this is the BMW measurement jig, and you have to make a modification for that so it actually works. And it's still not a perfect tool, but it does the job. There's ways to work around it. So this holds the bearing in position now, and then through this hole here, you measure down to the clamping surface, then you measure the height of the bearing that's around here. I've already done that, and I've gotten right around 12.70 millimeters of bearing protrusion above the clamping surface. So we're going to go ahead and take our fixture off because we know what that dimension is now. But we will go ahead and measure the cover here. And you just, this is just a Mitutoyo depth gauge. So I'm going to look at it here and say, we're going to come down to the clamping surface. I'm going to zero him, and then I'm going to come over to the bearing surface, and I'm getting 13.53 millimeters. We'll flip it around and just try the other side. We're still zeroed on the clamping surface. We come down, and again we get 13.53 millimeters. So we have 13.53 deep here. We have 12.7 that's using it up here. So a bit of math tells you that you've got 0.83 millimeters of difference between the two of them. BMW wants that 5 to 10 hundredths of compression. So if we average that out at 7, add that to the 0.83 of gap that we have with our particular parts, and you end up seeing that you need a 0.90 shim. And according to my measurements, when I put these out here, this is a 0.90. We can check it out. There you go, 0.90. So this shim should give us the compression that we're looking for. So I think it's time to button this guy up. I'm not going to even take the time to heat up this cover in the oven, because we can just do what we did before, heating them up with a torch. And we're going to give them a minute to cool down so that the cover is easier to install. I'm going to just set them upside down on here so that the weight of the ring gear holds that bearing tightly against the shim that's in the back of the bearing pocket. We'll give them a minute to cool down because the fit of the cover actually becomes very tight when the cover's hot and the housing isn't. So we're going to put our O-ring on, and when it's cool, we're going to button them up, and it should be done. Okay, we've given this a minute to cool down here. It's cool to the touch. So we're just going to take his parts bag here. Here's the O-ring. I don't always replace them. Sometimes there's a rough patch on them where they've been pinched. Sometimes they're just, you know, chewed up from corrosion. This one's in fine shape. We're just going to stretch that one back on. The O-rings for the Evo final drives that came in the mid-2000s generally are single use because they are too stretched out to reuse after you've taken them off. So here we go. Here are the. So when we put this together, we're going to be able to just give ourselves a little bit of a double check on the shimming. I'll show you what I mean by that. Just going to run these in really loosely. So if you feel this turn, it's really loose because the cover's not down all the way because the O-ring is holding it up. So now it's a bit more reasonable. So you can feel the friction, just the normal friction that's in here now. The pinion shaft has its seal installed, so there's a certain amount of friction you're going to get for that. And so you just turn it with your hand, just sort of feel how much friction is there. And then when you go ahead and snug this down the rest of the way, you should feel that it just gets a little bit tighter. And that's that 5 to 10 hundredths of a millimeter of compression that BMW wants in there, is just giving you that little bit more. So it doesn't really spin freely now. When you think about how this thing was shimmed, remember the shim that we took out of it was a millimeter thick. Well, before we even got to doing our cover shimming, we went down 2 shim sizes on the backlash shim. So what that did was it let this whole ring gear sit 0.1 millimeters lower in the housing. So it actually freed up 0.1 millimeters of space where the cover shim goes. But despite freeing up that 0.1 millimeters of space, we didn't take it up with an extra 0.1 millimeters of shim. We actually dropped our shim size 0.1 millimeters. So even you can feel that it's tightened up nicely. So I think our shimming is really good. But we are now shimmed 0.2 of a millimeter looser than this was when it was built last time. And that is probably why we're seeing it in here. Most of the ones that I see show signs of being shimmed too tightly. That 0.1 millimeter thick, that 1 millimeter thick shim that we had in their original, it's pretty much impossible that anyone is ever going to actually have a shim that big that's the correct shim. This feels perfect. So now we're just going to grab our output seal, make sure there's nothing on here. The seals go in pretty easily. Just going to make sure that none of the lips are folded over. Start to press them in by hand. And then what I'll usually do is just use a block of wood and start to work my way around. Pressing them down evenly. The block of wood keeps them from going in too deep because there's no positive stop on the inside for them. Pivot bearings feel good, so I'm not going to replace them. We have the 2 drain plugs in there, and I grabbed 2 fresh crush washers. So I'm going to put the drain plug in there. Once I blow the debris out of it, I always install the drain plugs tight. If you're not going to do them tight, there's no reason to put them in, because you'll just fool somebody. So I'm going to blow this metallic debris off the magnet here. You can see this is some residue from the failure. Blow that off, install it in there, and he's ready to go back on the bike. Hope you enjoyed watching this. I didn't go through the technical details of the measurement. That's something that is pretty much just for me. But the procedure that I went through is absolutely typical of every final drive that I do. Catch you later.